Welcome back to the 7th video in the Pearson Geometry series. Section 1.7 is the Pearson Introduction to Proofwriting. Most of this information will be familiar because of the work with proofs we did last week. Pause the video and take a moment to copy down the vocabulary: paragraph proofs, proof, theorem, and two-column proof. Now let's take a look at vertical angles. We're going to start by marking the congruent angles. When you're looking at vertical angles, it's usually pretty easy to see which ones are congruent. So the first set, angle 3 and angle 4, look like they're congruent, and so we're going to mark those with a single arc. That arc says that those two angles are the same. Their measures are the same, so the angles are congruent. Angle 1 and angle 2 also look like they'd be congruent. So we're going to mark those with two arcs. If we used one arc, it would say that all the angles were the same, and clearly 2 and 4 are not the same, and 1 and 3 are not the same. So we want to show that 1 and 2 are congruent, and 3 or 4 are congruent separately. Now, when we refer to angles, vertical means across from. And this is a little bit different than what we're used to. Generally speaking, vertical means straight up and down, especially when you're talking about lines, which we did a lot of in Algebra 1. But when we're talking about angles, it means across from. And the vertical angle postulate says that vertical angles are congruent. This is something that's going to come up when we're writing proofs. Okay, now let's talk about the congruent supplements theorem. If we look at what they have right here, it says if the measure of angle 1 plus the measure of angle 2 equals 180. So their measures add up to 180. So they're supplementary. And the measure of angle 3 and the measure of angle 2 adds up to 180. So those two are also supplementary. Then angle 1 is congruent to angle 3. Let's see if we can prove that mathematically. Let's say that angle 2 is 100 degrees. Okay, if angle 1 and angle 2 are supplementary, then angle 1 has to be 80 degrees. Okay, now let's look at angle 3 and angle 2. If angle 2 is 100 degrees, then that means that angle 3 must be 80 degrees. So looking at angle 1 and angle 3, their measures are equal. Therefore, the angles are congruent. So if we write out the congruent supplements theorem, then it's going to sound like this. If two angles, and I'm going to abbreviate, if two angles are supplementary, to the same angle, if two angles are supplementary to the same angle, the two angles are congruent. Okay, same thing can be said with the congruent complements theorem. In fact, it's exactly the same thing, except that we have two angles that are adding up to 90 degrees instead of two angles that are adding up to 180. So if we swap out supplementary for complementary, we have the same wording exactly. So if two angles are complementary, to the same angle, if two angles are complementary to the same angle, then the two angles are congruent. Okay, pause the video if you need more time to write that down. Otherwise, let's go ahead and flip it over to the other side. Theorem 1.4. Let's take a look at this picture. First of all, let's clear up a misconception right off the bat. This box, what do you think this box means when you see this box? Most people would say it's a right angle, or it means 90 degrees, and all of them would be wrong. This box merely means that these two lines are perpendicular. Now, we can make the leap that perpendicular lines create right angles, and right angles are 90 degrees. So syllogistically speaking, we can say that these boxes mean 90-degree angles, but in reality, those boxes show two perpendicular lines. Now, this angle right here, since we have already established that it's a right angle, we know that it is a 90-degree angle. Likewise, angle B, also established as a right angle, is 90 degrees. Now, can you think of any angles formed from perpendicular lines, so right angles, that measure something besides 90 degrees? Your answer should be no. And the reason is all right angles are congruent. And all right angles are congruent because all right angles measure 90 degrees. Okay, linear pairs theorem. Linear pairs theorem has to do with supplementary angles, but it's a little more specific than supplementary angles. It's a little more specific than supplementary angles that form a line. The two angles in a linear pair have to be adjacent, and that's a new word. So angle 1 is made up from this ray and this ray right here. Angle 2 is made up of this ray and this ray. So as you can see, they share a side right here in the middle. That's what we call adjacent. So to be a linear pair, they have to be two angles that are supplementary and adjacent. So we can say if two angles are supplementary, which of course means they add up to 180 degrees. If two angles are supplementary and adjacent, so they also share a side, then the two angles form a linear pair. Okay, let me read that back to you. If two angles are supplementary and adjacent, then the two angles form a linear pair. Okay, last theorem. Okay, we have two angles here that are congruent to each other. Okay, so we know they're congruent. We can mark them with an arc like we did on the other page. And we know that these two angles add up to 180 degrees. Okay, so we have two angles that add up to 180 degrees. These two angles have the same measure, so if we divide 180 by 2, we get 90, and that means that both angles measure 90 degrees. Okay, and then angle 1 and angle 2 are right angles. Okay, so we can say if two angles are supplementary and congruent, if two angles are supplementary and congruent, then they are right angles. If two angles are supplementary and congruent, then they are right angles. Well, this covers several of the theorems that we've been working with over the last week, and on your assignment you're going to be doing 3 proofs and some other algebraic equations that require the knowledge of these theorems in order to set up. So, good luck, and I'll see you back when we start on section 1.8, indirect proofs.